Today we're going to use what we've learned about adding and subtracting and multiplying polynomials to figure out the area and perimeter of some shapes. So first you see here a rectangle, and if you remember, the area of a rectangle can be figured out by doing base times height. So when you look at this rectangle, the base is a binomial, 4x plus 3. The height is a binomial, 2x plus 2. So we want to multiply those two together. So when we do that, it's going to look like this. We're going to have the base times the height, two binomials. And we have learned that when we are multiplying two binomials, that we use a method called FOIL, which leads you through the distributive property twice. So first we're going to multiply the first terms, 4x times 2x, which would be 8x squared. Then we're going to do the outer terms, 4x times 2, which is 8x. Then the inner terms, 3 times 2x, which would be 6x. And then the last terms, which is 3 times 2, which is 6. And then remember, when we use FOIL here in the center, we're going to find like terms, and we need to combine them together. When we do that, our final answer would be 8x squared plus 14x plus 6. Now, to figure out the perimeter of this rectangle, the perimeter is when you add all of the sides together. So if you look at the equation we have 2b plus 2h. That means we have the base twice. This is a base, and this is a base. We have it twice. So if we take that binomial, multiply it times 2, and then we take the height, which we have two of those, the right side and the left side. So we're going to plug those into the equation. So here was our base. We have two of them, so we're going to multiply that times 2. Here is the height. We have two of them, so we're going to multiply times 2. And if you notice here, we have a monomial times a binomial, so we're going to use the distributive property. 2 times 4 would be 8x. 2 times 3 would be 6. Now we're going to do the distributive property for this one. 2 times 2x would be 4x, and 2 times 2 would be 4. Now we're going to combine our like terms. We have 2x terms, and we have two constants that we're going to add together, and our final answer would be 12x plus 10. We can use the same thing when figuring out the perimeter of a triangle. We want to add together all of the outside dimensions. So we're going to call this side A, this side B, this side C. Remember with the Pythagorean's theorem, when you have a right triangle, that our legs are A and B and our hypotenuse is C, all we have to do is add three sides together. So we have three binomials that we're going to be adding together. So here the three are. Here's our A, here's our side B, here's our side C. To add those together, we're going to look for like terms. So when we group together all of the C terms, we have 6C plus 8C. So here's our 6C plus 8C plus 10C. We're going to combine them together. And then we're going to combine our constants together, 4 plus 1 plus 3. And when we do that, we get 24C plus 8. That's as far as we can go, and that is the perimeter of that triangle. Next, we're going to find the area of a shaded region. Now, if you look up here, we have two rectangles, and we want to know the area of the brick wall, but this part right here is not shaded, so it's the brick wall minus this part of the wall. In order to do that, it's going to take several steps. First, you have to find the area of the large triangle. Well, if we look up here at the large triangle, here is the base, and here is the height. So we remember that figuring out the area of a rectangle is base times height. So when I do that, here is the base, here is the height, base times height. Again, we have a binomial times a binomial, so we want to do our FOIL. So we do 3x times 3x, which is 9x squared, 3x times negative 1, which is a minus 3. And the distributive property with the 7, the inner terms, 7 times 3x would be a positive 21x. And 7 times negative 1 would be negative 7. Again, here in the center, I forgot to put my x right there. Sorry about that. We have like terms, and when we have different signs, we subtract and keep the sign of the greater number. So it would be 9x squared plus 18x minus 7, and that is the area of the large rectangle. Now we want to figure out the area of the small rectangle. If you look up here, here is the base and here is the height. So base times height, but when you have a monomial and a binomial, you always want to set it up with the monomial first. So we're going to do height times base, which is going to result in the same answer. So we're going to set it up like x, the height, times the base, which is a binomial. Now we're going to do our distributive property, and x times 2x is 2x squared, and x times 5 is 5x. If you look there, you'll notice that there are no like terms, so we're finished adding. Now, we remember back the original thing was we wanted to find the area of the shaded region. So now we're going to have to subtract the smaller area from the larger one. Remember that when we're subtracting with polynomials, you add the opposite of each term in the smaller polynomial. Remember, we have negative minus this, so you have to change each one of these terms to the opposite sign. So I'm going to take the area of the large rectangle, which was 9x squared plus 18x minus 7, and I'm going to add the opposite. I'm going to add the opposite of each term in the one that we're subtracting from. So instead of a positive 2x squared, we're going to do a negative 2x squared. And instead of a positive 5x, it's going to be a negative x. And I have aligned them vertically here with like terms. So now when we combine the like terms, the area of the shaded region would be 7x squared plus 13x minus 7. This is some examples off of your assignment today, and I'm just going to work through one of each column. Again, here we have the perimeter of a triangle, so we want to add together these three sides. So when I look over here, I can see that I have three x terms. So I'm going to add 3x plus 4x plus 5x. And then I'm going to add together my constants. I have an 8, a negative 1, and a positive 2. So I have an 8 and a negative 1 and a positive 2. So I'm going to combine together all of the x terms. And then I'm going to combine together all of the constants. And when I do that, I would get 12x. And over here, when I add these together, I would get plus 9. So there is the perimeter of that triangle. Now, when we look at part 2, where we're finding the missing side, this time we're giving two sides of the triangle, and we're given the perimeter, but we need to find this missing side over here. This is the missing side. So in order to do that, we want to add together the two sides that we have that are shown. So we can see that we're going to add together a 3x minus 2 and a 6x plus 6. If I look at my like terms, I have a 3x and a 6x. I'm going to combine them together and get 9x. I also want to combine together the minus 2 and the plus 6. Different signs subtract and keep the sign of the greater value, so that's going to be plus 4. So when I add together the two sides that are there, I get 9x plus 4. Now, I want to subtract that from the perimeter. The perimeter is right here, 13x plus 11. Remember, when subtracting with a polynomial, we're going to have to change the sign of each term with the polynomial that we're subtracting from. So I'm going to take the perimeter, which was 13x plus 11. Now, when subtracting this polynomial, instead of a positive 3x, it's going to be a negative 9x. I think I said 3x. It was a positive 9x. Now I'm going to subtract a 9x. Instead of a positive 4, I'm going to subtract 4. So each term in this polynomial became the opposite sign. Now I add them together, and I would see that I get 4x plus 7. So it takes several steps, but we can get through this. So see what we did? We added the two sides together and then subtracted from the perimeter. On the next two, parts 3 and parts 4 of your paper, on part 3, it's find the area, okay? To find the area, remember, area is base times height. So we want to take the base, which is 8x minus 5, and multiply it times the height, which is 3x. One of those is a monomial, so we want to put it on the outside. So we're going to multiply the 3x times the binomial, 8x minus 3. And here we just use the distributive property like we've learned. So first we do 3x times 8x, which is 24x squared. Then we have 3x minus 5, which is a negative 15x. And you're done. There's the area of that rectangle. On part 4, this is where we find the area of the shaded region. So this is where you have 3 parts again. You have to find the area of the large rectangle, find the area of the small rectangle, and then subtract them. So let's start with the large rectangle. Here is the base, 16x plus 5, and here is the height. We want to multiply them together. So I'm going to put the monomial on the outside and the binomial on the inside, 16x plus 5. Now I'm going to multiply those together. 16 times 9. 16 times 9. We have a 4. Carry the 4. 144. So we have 144x squared. And then we have 9x times 5, which is a 45x. So we have figured out the area of the large rectangle. Now we have to figure out the area of the smaller rectangle. So we have the base of 7x minus 2 and a height of 4x. So I'm going to put my monomial on the outside. I'm going to do it right here. So we have 4x, if that's going to show up on my smartboard, 4x times 7x minus 2. Now we're going to multiply those together. So we have 4x times 7x, which would be 28x squared. And we have 4x minus 2, which would be negative 8x. Now we want to subtract this entire polynomial from the large rectangle. But remember, when subtracting with polynomials, we're going to change each term over here to the opposite sign, and then we're going to add. So we're going to have a negative 28x squared, and we're going to have a positive 8x. And I have aligned them vertically here so that my x squared terms are aligned and my x terms are aligned. 144 minus 28 is 116x squared. And 45 plus 8 is 53x. So I have figured out right here the area of the shaded region. It just took several steps, but we can do this. Good luck with finding the area and perimeter of shapes.